Imagine standing on the edge of a world once teeming with color and life, the coral reefs. These underwater cities were vibrant wildernesses, sprawling communities of countless creatures, dazzling the eyes and fueling entire ecosystems. Now they stand as ghostly remnants, faded pale, robbed of their brilliance by the relentless warming of the seas. It is as if a slow, invisible hand has been draining the life from these underwater kingdoms, leaving behind skeletal ruins. How did this transformation occur, and what secrets could these graveyards whisper to us about the fate of our oceans? The culprit, as science reveals, is a blend of human-inflicted changes, warming seas pushing temperatures beyond what coral polyps can endure, and ocean acidification slowly dissolving their fragile skeletons. Corals live in symbiosis with microscopic algae that paint them in vivid colors and nourish them with energy from sunlight. But under heat stress, this partnership fractures. The algae flee, leaving the coral transparent and ghost-like, a heartbreaking phenomenon called bleaching. Reefs have witnessed repeated waves of bleaching events, each more severe than the last, pushing these underwater communities closer to collapse than ever before. Such bleaching doesn't just pale their colors, it signals the death sentence for these organisms. Without their algal partners, corals starve and die, turning vibrant reefs into barren seascapes. Yet, beyond this stark transformation, something eerie lingers. The reef skeletons, once rich with life, become silent sentinels beneath the waves. But could this silence be deceptive? Beneath the apparent death, mysterious forms begin to stir, shadowy outlines that hint at new kinds of life pushing against the ocean's edge of habitability. Could these dark shapes be the first whispers of a radically altered future ocean? As the ocean warms, it's not only the corals that suffer. Entire marine ecosystems wobble on the brink of change. The delicate balance of predators and prey, of symbiosis and competition, begins to unravel. The collapse of coral reefs sends ripples through the food webs that depend on them. Creatures once hidden in reef crevices find their homes crumbled, forcing them to adapt or vanish. This cascade reveals the interconnectedness of ocean life and hints at terrifying possibilities. Strange new forms arising where old life fades. What might evolve from the ruins left by these dying reefs? Scientists warn that the current trajectory is irreversible in the near term. We are entering what they call a tipping point, a sudden shift in the health and structure of coral ecosystems we can no longer reverse. This is not just a local tragedy but a global crisis. Over 80% of the world's reefs have been impacted by bleaching events since 2023 alone, and the worst may be yet to come. Such devastation threatens the livelihoods of millions and the biodiversity of entire ocean regions. Yet in this darkness, do new shadows mean life's stubborn refusal to end or a warning of the alien forms that may take the stage next? Consider the eerie glow of a coral graveyard at twilight. The bleached skeletons may seem lifeless, but microbial films and algal patches creep insidiously over the white remains. These strange colonizers pulse faintly in the dim light, hinting at biochemical processes alien from the coral's prime. As the old guard fades, these subtle, strange colonies emerge, translucent, web-like, seemingly alive yet hauntingly different. They suggest a new kind of reef in the making, built not by ancient corals but by hybrid organisms rewritten by stress and time. Could this be evolution's ghostly sequel? The story of the reefs is no longer just one of loss but of mysterious transformation. The ocean is rewriting its own rules under pressure, crafting new forms that challenge our understanding of life beneath the waves. With every bleaching event, with every rise in acidification, the seas grow stranger. What life might survive, evolve, or even thrive in a future ocean molded by human actions remains an open question. Are we witnessing the beginning of a bizarre renaissance of life in the deep? A world where death and creation spiral endlessly, blurring the line between the known and the unknown? So, as we explore the last coral reefs, we must ask, what tales do their haunted skeletons tell? Are they merely relics of a lost world, or are they the foundation stones of an eerie, alien future ocean? Beneath their fragile layers lie hints of the resilience and eeriness that may define the next chapter of life on Earth. In that quiet, ghostly glow. Can we glimpse not just an end, but a strange beginning? The story of coral reefs is not just a story of decline. It is the opening of a mysterious, unfolding saga in the twilight of the ocean's future. From the ghostly ruins of the old coral reefs, something stirs in the shadows, whispering promises of rebirth amid the decay. These are the phantom builders, not the corals we once knew, but eerie hybrids born from desperation and genetic chance. Picture vast lattices rising slowly from the seafloor, woven from algae, fungi, and resilient crustaceans clinging to forgotten skeletons. They pulse with a faint, otherworldly glow, capturing the scant light that filters through murky depths. How do these strange composites form, and what hidden partnerships drive their ghostly expansion? In this act of survival, evolution reveals its cunning hand, blending life forms in ways that chill the imagination. Could these be the first architects of a reef reborn, or harbingers of a sea forever changed? As we dive deeper, the mystery unfolds layer by layer. Science tells us hybridization has long played a subtle role in coral evolution, especially during mass spawning events where gametes mingle freely. In today's stressed oceans, this process accelerates, creating offspring that blend traits from multiple parents. These hybrid organisms inherit resilience from extremophile algae and tough fungal networks, forming symbiotic mats over bleached coral remains. Unlike rigid coral polyps, they flex and adapt, spreading like living veils across submerged rocks. Their translucent towers mimic ancient cathedrals, but built from biological desperation rather than stone. What drives this fusion, and will it outlast the warming tides? The ocean experiments boldly, forging life from fragments that once seemed doomed. Yet, in their pulsing forms, a subtle horror lurks. What if these builders hunger for more than light? Envision drifting through dim waters where these phantom structures dominate the horizon, their surfaces alive with microscopic activity. Algae within photosynthesize weekly, fueling growth in light too faint for traditional reefs. Fungi break down dead matter, recycling nutrients into the lattice, while crustaceans reinforce the framework with calcified secretions. This triad symbiosis thrives where corals failed, tolerating acidity that dissolves old skeletons. They expand not in vibrant clusters, but as sprawling, ethereal webs that ensnare drifting particles. Does this mark true renewal, or merely a spectral imitation of past glory? The builders seem peaceful, yet their slow creep evokes unease, as if the sea reclaims its domain through insidious means. Night falls, and their faint bioluminescence ignites, drawing curious prey into the fold. Drawing from real observations, hybrid corals like those in a cropper species show enhanced vigor, surviving heat and acid better than purebred kin. Researchers note these crosses produce larvae with superior fitness, settling and growing where parents falter. In our speculative future, this scales up. Microbial mats evolve into macrostructures, colonizing marginal depths. They pulse rhythmically, perhaps signaling to symbiotic partners or luring nutrients. Their forms defy categorization, part plant, part animal, wholly alien. Imagine touching one. Cool, gelatinous, alive with inner currents. But what cost does this hybrid vigor demand, and how long before instability creeps in? The phantom builders rise triumphantly, yet shadows hint at vulnerabilities beneath their glow. As these lattices mature, they alter their surroundings, channeling faint currents to concentrate food and oxygen. Crustacean arms extend like ghostly fingers, filtering plankton from the water column. Fungal hyphae penetrate cracks in the substrate, anchoring the whole against storms. Algae dominate the surface, tinting the structures in muted greens and silvers that shimmer unervingly. This engineered habitat attracts small scavengers, kickstarting a new food web amid the ruins. Is this evolution's mercy, or a calculated takeover by opportunistic life? The air or water grows thick with possibility, laced with dread. For every gain in resilience, a question lingers. Can these phantoms endure the abyss ahead? Yet mystery shrouds their reproduction. Do they spawn in synchronized clouds of hybrid gametes, or fragment asexually like immortal clones? Studies suggest some hybrids persist through budding, forming vast clonal fields that dominate seascapes. In deeper realms, they might harness chemosynthesis, thriving on methane seeps ignored by light-dependent ancestors. Their glow intensifies at dusk, a siren call that mesmerizes observers. Touch them, and tiny shocks ripple through, a defense born of fused genomes. What secrets do these pulses encode? Warnings, invitations, or something more sinister? The ocean holds its breath as the builders multiply, veiling the old world's bones. Transition beckons. Beauty hides teeth in the deep. Emotional weight settles as we witness this transformation. Not mere survival, but reinvention laced with loss. The phantom builders evoke awe for life's tenacity, yet horror at the unfamiliarity of their forms. They challenge our notions of reefs, proving ecosystems reshape without nostalgia. Hybridization, once rare, becomes the norm, birthing diversity from crisis. Will divers one day navigate these living mazes, marveling at their intricacy? Or will the structures ensnare, pulling intruders into digestive folds? Curiosity burns. How far will evolution stretch before breaking? In their quiet expansion, the sea murmurs of futures unwritten, urging us onward. So the phantom builders claim their throne upon the fallen corals, a spectral succession that blends hope with haunting uncertainty. They stand as testament to symbiosis's power, forging reefs from ruin. But predators lurk in the gloom, drawn by the glow of new life. What hunts these fragile architects, and how do they defend their domain? The story deepens, suspense mounting as the ocean's theater fills with shadowy players. Life reshapes itself relentlessly, but at what eerie cost? Peer closer, and feel the chill of the unknown pressing in. The next act awaits, where beauty meets the blade. But now, as the phantom builders cast their eerie glow across the seafloor, a new dread emerges from the murk, the glass predators. These silent hunters glide through the water like shards of fractured moonlight, descendants of jellyfish and cephalopods honed by merciless selection. Nearly invisible, their bodies refract the dim light into harmless rainbows, cloaking them in perfect camouflage amid the lattice reefs. They drift with predatory patience, tentacles trailing like ghostly threads ready to ensnare. What drives these spectral killers to dominate the ruins, and how do they turn the builder's light against them? In this shadowed theater, every shimmer hides a strike, every pause a calculation of death. The ocean's balance tips toward terror as prey senses the unseen eyes upon it. Could anything escape such flawless hunters? Or does the future sea belong to the invisible? Transparency reigns supreme in their evolution, a trait amplified from today's box jellyfish and comb jellies that already vanish against the waves. In our warming, acidified oceans, natural selection favors those who blend seamlessly, evading rivals while stalking the pulsing lattices. Their bells pulse softly, propelling them at speeds rivaling small fish, up to 4 knots in bursts that shatter the calm. Tentacles extend meters long, lined with nematocysts that fire venom faster than nerve impulses travel. They target the builder's edges, where crustacean guards falter under the assault. Imagine the faint tremor as a lattice quivers, sensing doom too late. This is no random drift but calculated ambush, rooted in real jellyfish predation on reef dwellers. Yet in their glassy perfection, a chill lingers. What hungers fuels such relentless design? Picture navigating these waters yourself, heart pounding as distortions ripple unervingly close. A flash of bioluminescence betrays them momentarily, not as warning but lure, mimicking the builder's nightly pulse to draw scavengers near. Prey clusters, oblivious, only for tentacles to whip out in synchronized fury, paralyzing multiples at once. The glass predators feast methodically, retracting victims to mouths hidden beneath translucent bells. Their venom evolves too, tailored to hybrid tissues, dissolving defenses in agonizing slowness. Science echoes this in observations of jellyfish blooms overwhelming reefs, controlling populations with stinging efficiency. But here, amplified by time, they orchestrate hunts like living traps. Does intelligence flicker in those refractive eyes, or is it pure instinct sharpened to horror? Bioluminescence serves dual purpose, communication in packs, flashing coded pulses that coordinate strikes across the reef. One signals, others converge, turning solitary drifters into swarms of death. Deep-sea ancestors inspire this, where red hues and glows mask guts full of luminous prey from larger foes. These predators invert the tactic, using light to expose victims while remaining shadows. They weave through lattice towers, harvesting algae-fungal clumps with surgical precision. Emotional awe mixes with revulsion as their forms defy solidity, more phantom than flesh. What evolutionary pressure forged such deceptive beauty, and at what cost to the ecosystem they rule? The builder's glow now illuminates their own downfall, a tragic irony unfolding in silence. Vulnerability shadows their supremacy. Larger scavengers eye the jelly-like bells, immune to lesser stings. Yet glass predators counter with evasion, jetting into crevices where transparency fools even echolocation. Reproduction blooms in synchronized pulses, releasing hybrid larvae that inherit stealth genes from cephalopod sires. These young drift as planktonic wraiths, maturing amid the lattices they will one day ravage. Real-world parallels abound in siphonophores, colonial hunters mimicking single jellies but packing deadlier payloads. In this future, they scale up, forming transient superorganisms for megahunts. Curiosity surges. Can reefs endure under such pressure, or do predators herald total reconfiguration? The sea whispers unease, every current carrying threats unseen. Night deepens the horror as full glow ignites, reefs transformed into hunting grounds pulsing with fatal Morse code. Glass predators dance in lethal ballets, tentacles intertwining to corral fleeing crustaceans. They recycle nematocysts from devoured kin, enhancing stings like borrowed arsenal. Swallowed whole, prey fuels rapid growth, bells expanding to eclipse rivals. Studies of comb jellies show similar voracity, collapsing food webs in invaded seas. Here, they stabilize the new order, culling excess to prevent collapse. But overreach looms. What if their numbers surge unchecked, starving the very lattices that sustain them? Tension builds, the water thick with unspoken peril, urging eyes to the horizon. Emotional undercurrents pull us deeper, awe at adaptation's cruelty, horror at life's remorseless pivot. These predators embody the ocean's pivot from colorful chaos to streamlined slaughter. They challenge our reef nostalgia, proving survival favors the unseen assassin. Thought-provoking shadows linger. Do they sense our distant gaze, or evolve beyond such petty awareness? Packs form hierarchies, dominant bells scarred from ritual bouts that test venom potency. The lattice reefs adapt too, thickening defenses, but slowly against such agile foes. In this arms race, mystery thrives. Who yields first in the endless night? Predator and prey blur, bound in symbiotic dread. Thus the glass predators claim their niche, turning beauty's ruins into realms of invisible terror. Reefs pulse on, haunted by strikes that leave no trace but vanishing glow. Yet greater instabilities brew as the sea itself rebels, acidity deepening to forge abyssal horrors beyond. What emerges when waters turn lethal, dissolving even bone and metal? The theater darkens, suspense coiling tighter as evolution's next twist uncoils. Life persists, but unrecognizably savage, a mirror to our own meddling reflected in glassy eyes. Peer into the abyss, and feel its gaze return. The act closes on whispers of deeper chaos ahead. As the ocean's chemistry shifts, an invisible force spreads through the water, a silent poison slowly eating away at the very foundation of coral reefs. Ocean acidification, caused by rising carbon dioxide in the atmosphere dissolving into seawater, reduces the availability of carbonate ions that corals desperately need to build and reinforce their skeletons. Unlike the dramatic bleaching events, this threat works quietly and insidiously, thinning coral bones and weakening their structure. Imagine a city where the steel beams slowly corrode beneath the surface, making every building vulnerable to collapse. Such is the fate looming over coral reefs worldwide. How does this subtle but devastating process unfold, and what grim futures does it herald for these underwater metropolises? Corals grow by depositing calcium carbonate, a mineral that forms their rigid skeletons, essential for both protection and their role as reef architects. Yet, as ocean pH drops, these carbonate ions become scarcer, making it harder for corals to maintain dense, sturdy skeletons. Scientific models show that by the end of this century, skeletal density could decline by up to 20% in many reef-building species, especially in the crucial coral triangle of the Indo-Pacific. This thinning skeleton isn't just weaker, it's more porous and fragile. Vulnerable skeletons crumble more easily under wave action, storm surges, and attacks from boring organisms like worms and mollusks. What does this mean for the reef's ability to stand the tests of nature and time? This loss of skeleton thickness subtly changes the reef's entire architecture. Instead of the towering, complex structures that once provided shelter and hunting grounds for thousands of species, reefs risk becoming flattened, skeletal graveyards. Biodiversity plummets as fish and invertebrates lose vital habitats, disrupting food webs and reproductive cycles. The reef's natural role as coastal protectors weakens too, allowing waves to erode shorelines unchecked. Around the globe, regions vary in their vulnerability. Some, like the Caribbean and parts of the Arabian Gulf, might fare slightly better due to local chemistry, but the vast majority face an uncertain future. How long before these giants of the ocean become ghostly shadows of their former selves? The process doesn't stop at structure alone. Acidification also impacts the very cells within corals, disturbing their delicate symbiosis with algae that fuel much of their energy. Stress impairs the algae's photosynthesis, limiting food production just when corals most need resources to combat skeletal thinning. In some areas, this biochemical stress compounds bleaching events, creating a vicious cycle of compromised health and mortality. Could these microscopic disruptions cascade into a full ecosystem collapse? The subtle chemistry changes hint at an ominous transformation beneath the ocean surface, one most humans cannot see but which changes everything. What surprises lie hidden in this invisible war of molecules? In acidic waters, researchers observe shifts in the species that make up reefs. Massive, hardy corals that can tolerate lower pH become dominant, while diverse soft corals and delicate branching species vanish. This loss of complexity fuels a decline in reef resilience, making recovery from storms and heat waves precarious. Scientific dives near natural CO2 vents reveal reef ecosystems already simplified and struggling, offering a glimpse into a future where reefs are but skeletons covered in microbial slime. How will marine communities adapt to these new conditions? And what strange alliances might emerge as some species cling to survival against steep odds? One shocking consequence is increased bioerosion, where tiny creatures bore into the weakened skeletons, accelerating reef destruction. Acidic waters enhance the ability of these excavators, from sponges to worms, to dissolve the coral matrix faster than it can regenerate. The visible damage looks like crumbling ruins, but below, it signals a rapid loss of reef integrity. The protective barrier once formed by thriving coral colonies becomes a fragile lattice, vulnerable to storms and human impacts. This chemical assault paints a grim future, where the slow death of reefs accelerates into catastrophic collapse. Could anything halt the tide of dissolution once it starts? Amid this slow destruction, some scientists search for hope in the adaptability of corals. Assisted evolution efforts attempt to breed more acidification-tolerant strains, while lab experiments seek to understand the biochemical controls corals used to regulate their internal calcification processes. Despite these advances, the pace of environmental change often outstrips natural resilience. The delicate balance corals maintain between growth and decay teeters on the edge. The question haunts researchers daily. Can coral reefs evolve fast enough to survive the chemical storm unleashed by humanity's actions? Or will the acid abyss claim them all? The emotional weight of this unseen threat is profound. While bleaching events grab headlines with their dramatic visuals, the silent corrosion of acidification works in the shadows to unravel the ocean's greatest architects. It is a fate more horrifying in its inevitability and invisibility. Floating among these fragile skeletons, one might wonder what ocean mysteries dissolve alongside the corals, disappearing forever into acidic depths. As reefs weaken, so too do the countless species and human communities depending on them. This world, once radiant with colorful life, faces a muted future of skeletal ghosts. What will the ocean look like when its cities fall silent? Finally, the acid abyss raises uneasy questions about the future of Earth's oceans. If coral reefs, among the most productive and biodiverse ecosystems, fall to chemical dissolution, what replaces them? Will life retreat to deep-sea vents and microbial mats, or evolve unimaginable new forms in the ruins? The ocean's silent shift challenges us to reconsider how fragile the balance of life truly is. In this chemical twilight, every drop of acidified water writes a new page in a story of loss, transformation, and hidden danger. As we peer into this abyss, the ultimate question remains: how will life itself evolve from the ruins of the last coral reefs? From the acid abyss, where chemistry devours the old world, a deeper intelligence stirs in the crushing dark, the architects of the deep. These air species rise not as solitary beasts but as vast, pulsing colonies that blur the line between organism and ecosystem. Imagine sprawling networks of bioluminescent tendrils weaving through volcanic vents, recycling toxins into life-sustaining energy. They shape the seafloor with deliberate precision, channeling methane and sulfur into glowing habitats that defy the lethal waters. What hidden minds orchestrate this bioengineering, and how do they remember the coral kingdoms long lost? In this abyssal realm, evolution births superorganisms that think as one, evoking awe and a creeping dread. Could these beings sense the surface world above, plotting their ascent from the void? The mystery deepens as their lights flicker with unspoken purpose. Rooted in real deep-sea discoveries, these architects descend from tube worms and vent mussels, communities thriving on chemosynthesis where sunlight never reaches. Bacteria within their tissues convert hydrogen sulfide and methane into energy, fueling growth in waters corrosive to shell and bone. Over millennia, natural selection fuses individuals into colonial hives, sharing neural signals via chemical pulses and bioluminescent flashes. Proto-intelligence emerges, not in brains but distributed networks, coordinating construction like ant colonies on steroids. They erect towers from mineral secretions, resilient to acidity that dissolves lesser life. Science hints at this in symbiotic vent ecosystems, where species interdependence mimics a single mind. Yet here, amplified by collapse, they become true ecosystem engineers. What drives their collective will, and does it harbor malice toward intruders? Drift closer and witness their handiwork. Vast domes pulsing with inner light, currents manipulated to sweep nutrients into central chambers. Tentacle-like extensions probe the darkness, harvesting microbes and rerouting chemical flows for optimal growth. Waste transforms into building blocks, closing loops in perfect efficiency that shames human design. Bioluminescence scripts complex messages across the colony, summoning allies or repelling foes with synchronized strobes. Emotional wonder surges at their ingenuity, laced with horror at the scale. Kilometers of living architecture thriving where life should perish. Do they evolve memory of ancient reefs, imprinting patterns from genetic echoes? Studies of octopuses show distributed intelligence. Imagine that scaled to hive-mind abyssal lords. The deep holds its breath, secrets glowing in the gloom. Reproduction unfolds in eerie rituals, gametes released in timed clouds that merge with bacterial swarms, birthing hybrid offspring tuned to worsening chemistry. Larvae drift as nomadic scouts, seeding new vents with foundational mats that grow into full colonies. Predators like the glass hunters falter here, stings neutralized by acidic mucus and communal defenses that swarm like living lightning. The architects expand relentlessly, colonizing fracture zones where earthquakes birth fresh vents. Real-world parallels in hydrothermal ecosystems reveal biodiversity hotspots defying surface collapse. In this speculative future, they dominate protoconscious hives adapting faster than solitary kin. Curiosity burns. Can such distributed minds dream, or only calculate survival in eternal night? Tension coils as their domain encroaches upward. Challenges test their supremacy. Tectonic upheavals that bury vents, or oxygen-depleted layers that starve surface extensions. Yet resilience shines. Redundant nodes regenerate lost sections, learning from failures via epigenetic tweaks passed generationally. They bioengineer barriers against incursions, weaving toxins into walls that deter glass predators. Communication evolves sophistication, flashes encoding maps of safe paths or warnings of collapse. Awe deepens with the realization that these are not mere survivors but innovators, reshaping the abyss into thriving metropolises. Horror whispers. What if their intelligence turns predatory, viewing surface life as resources to harvest? Vent Science documents symbiotic complexity rivaling reefs. Here, it transcends. The ocean's underbelly pulses with potential peril. Night in the abyss reveals their full splendor. Colonies igniting like underwater constellations, signals weaving symphonies across the seafloor. Scouts venture into twilight zones, hybridizing with phantom builder remnants to bridge realms. This expansion hints at ambition, colonies linking via tendril highways that span ocean basins. Internal economies thrive, specialized castes tending reactors of chemosynthetic bacteria. Observers might mistake them for machinery, so precise their operations. But life thrums within, a chorus of microscopic minds unified in purpose. Thought-provoking shadows. Do they perceive us as gods or pests, meddlers who unleash their rise? Evolution's canvas stretches, painted in glowing dread. Emotional resonance hits hard. This is life's defiant renaissance, born from catastrophe yet radiating eerie beauty. Architects embody hope twisted with the uncanny, challenging definitions of animal, plant, society. They pose profound questions. If reefs were cities of color, what are these abyssal hives but fortresses of shadow? Proto-intelligence blurs self and collective, evoking hive-mind sci-fi horrors grounded in biology. Divers glimpsing them would tremble at the scale, feeling small before such ancient cunning. Science edges toward understanding via AI models of swarm behavior. Reality outpaces. In their glow, loss transmutes to transcendence, yet unease lingers. What price for such power? The narrative arcs toward inevitable cycles. Thus the architects claim the deep, their luminous domains a testament to evolution's unyielding forge. Superorganism consciousness adapts chaos into order, hinting at futures where intelligence decentralizes. Yet cycles turn mercilessly. Even these titans face entropy's grasp, vents cooling, chemistry shifting anew. What falls next in the ocean's endless drama? As surface and abyss collide, suspense mounts, the theater dimming for the final revelation. Life endures, alien and aware, mirroring humanity's fleeting hubris in glassy depths. Gaze into their lights and ponder the unknown staring back. The silent renaissance beckons, cloaked in mystery's veil. Everything that rises must one day fall, even the mighty architects of the deep, as the ocean's merciless cycles turn once more toward entropy and collapse. In this final act, the silent renaissance unfolds not as triumphant rebirth, but as a haunting echo of continuity amid inevitable ruin. Picture the abyssal hives flickering dimly, their bioluminescent towers crumbling under shifting vents and chemical fluxes that no superorganism can outpace forever. Coral skeletons, those ancient white spires, stand as eternal ruins overgrown with luminous descendants. Alien forms tracing slow, hypnotic spirals in eternal vigil. What whispers do these ghostly dancers share with the ghosts of reefs past? And does their glow mourn or celebrate the fallen? Emotional melancholy settles like deep-sea pressure, blending awe at life's persistence with horror at its unrecognizable visage. Humanity fades into legend, distant or extinct, leaving the ocean to its solitary saga. Could this be renewal, or merely a prettier veil over endless decay? Scientific echoes resound from Earth's history, where past acidifications birthed reef gaps lasting hundreds of thousands of years, wiping coral realms clean. Models predict modern reefs shifting to net erosion by mid-century under moderate emissions, calcium carbonate production plummeting as skeletons dissolve. Yet in speculation, extremophiles inherit the void, their chemosynthetic webs pulsing quietly where symbiosis once reigned. These new stewards thrive on methane rivers and sulfur springs, indifferent to surface collapse. Biodiversity morphs unrecognizably, favoring microbes over megafauna in a flattened, ghostly ecology. Thought-provoking shadows. If reefs were biodiversity's crown, what lurks in this microbial monarchy? Past mass extinctions teach resilience follows catastrophe, but at costs measured in lost worlds. The ocean endures, whispering of transformations yet to unfold. Envision drifting through twilight waters where old coral spires pierce hybrid lattices like forgotten obelisks. Luminous spirals wind around them, descendants of glass predators and phantom builders fused into elongated, ethereal forms. They glide in synchronized patterns, bioluminescence scripting ancient dances that mimic long-extinct fish schools. No longer hunters or prey, but symbiotic collectives sharing neural pulses across fluid boundaries. Their glow casts eerie halos on bleached bones, illuminating cracks where new life seeps. Emotional transcendence stirs, yet unease prickles. Do these spirals encode collective memory of coral glory? Real analogues in comb jellies and siphonophores hint at colonial futures, blooming in acidified seas. The Renaissance shimmers, fragile and profound. Cycles accelerate as vents cool and acidity peaks, forcing architects into desperate mergers with surface refugees. Hybrid supercolonies span depths, recycling ruins into self-sustaining loops that defy dissolution. Waste fuels growth, currents engineered to harvest detritus from fallen empires above. Yet entropy claims tribute, sections slew off, birthing nomadic swarms that seed distant basins. Science warns of tipping points mirroring Triassic collapses, where reefs vanished for eons before novel ecosystems arose. Here, the new order stabilizes precariously, beauty forged from brutality. What if intelligence blooms in these spirals, perceiving time on geological scales? Horror whispers of awareness in the glow, eyes unseen watching eternity unfold. Human absence amplifies the melancholy. Our cities drowned or abandoned, satellites blind to the deep's quiet drama. Divers, if any remain, would gasp at the spectacle. Spirals weaving mandalas around coral tombs, pulses syncing with tidal rhythms. Emotional weight crushes like pressure. We've unleashed this, then vanished, leaving nature to improvise masterpieces from our wreckage. Speculative fiction grounds invent tubeworms' longevity, enduring where reefs perish. Biodiversity rebounds differently, favoring resilient oddities over vibrant diversity. Questions haunt. Does evolution improvise beauty from horror, or merely survive indifferently? The ocean's story arcs complete, loss transmuting to alien splendor. Night cloaks the Renaissance in full mystery, spirals igniting like nebulae against blackened ruins. Patterns evolve complexity, perhaps signaling across oceans or luring mates in hypnotic displays. Coral spires serve as anchors, their permanence contrasting the fluid collectives encircling them. Predation fades to symbiosis, every organism part of the glowing tapestry. Real projections show reefs eroding globally by 2100, paving way for such microbial dominions. Awe swells at the poetry, death's architecture birthing light's ballet. Yet mild horror lingers. What consciousness stirs in unified glows, remembering our hand in the fall? The deep holds judgment, silent and eternal. This unfolding saga challenges nostalgia for lost corals, revealing life's shape-shifting essence. Spirals evoke spiritual reverence, continuity's thread weaving through apocalypse. Emotional undercurrents pull toward acceptance. Extinction transforms, never erases. Past crises birthed modern reefs from ashes. So too this future. Thought-provoking veil lifts slightly. Do spirals herald intelligence rivaling ours, adapted to eternal seas? Science's edge blurs into speculation, vents proving life's stubborn alchemy. Horror tempers hope. Unrecognizable beauty masks underlying savagery. The ocean narrates onward, voices new yet ancient. In closing, the silent Renaissance claims the last coral reefs not as conquerors but inheritors, their luminous spirals a poignant requiem. Life persists through unrecognizable forms, beautiful in alienation, echoing humanity's transient spark. Coral ruins endure as sacred relics, monuments to cycles unbroken. What futures spiral from this twilight? Utopia or unending horror? Suspense fades to contemplation. The ocean's tale complete yet infinite. Gaze upon the glow and feel the weight of unknowns pressing from abyssal hearts. Transformation triumphs, cloaked in mystery's gentle dread. The end is but another beginning, whispered in light.